Right, what we're going to do is look at solving using unknowns in simultaneous equations here, okay? So this is really different. Instead of just having 3x plus 2y or just some numbers out the front, what we've actually got is letters. So there's m take 2 there, there's an m there, there's a k here, okay? So it's very different. So what you need to realise is when there's letters, all of a sudden we have to start looking at all the possibilities. Now there's 3 possibilities when we have straight lines. These are straight lines, guys. You could have a unique solution, and that's what you're used to. A unique solution is when you have one answer, a point. X is this, Y is that. You could also have no solution. Now this you may have not seen before, but it should make sense. No solution means that there's 2 lines that are parallel, okay? No solution. Are they ever going to intersect? No. So what you notice here is the gradient's the same. And the last type is infinite, where it's kind of silly, but because there's unknowns, you can actually have the same line. So if you can substitute the right value for m and the right value for k, you could maybe create the same equation. So that's what infinite means. How many times do they intersect? Well, supposedly they're actually infinite. So the question here is saying, find the values of m and k so that there are a unique solution, no solution, infinite. Now this is the way you should start every single question. You do this. Now we know that AD minus BC cannot be equal 0 for unique solutions. That's basically it. Now if AD minus BC did equal 0, what we're going to get is the possibility of either parallel or infinite. Okay? Because they're basically situations where there's no answer. There's no answer for this one, and there's infinite for this one. Another way of saying infinite is saying there's no real answer for it, okay? So all we simply do is go AD minus BC, and then we don't want it to equal 0 for unique solutions. So watch this. You should realise that A is m take 2, D is our bottom value here, which is 2, so it's AD, minus B, which in this case is 1, multiplied by C, which in this case is m. Okay, that cannot equal 0. Let's quickly solve this inequality. So I've really got 2 times m take 4, take m cannot equal 0. Okay, 2m take m is just m, m take 4 is that. So m cannot equal 4. So I've actually just found out quickly that there is going to be unique, meaning there's always going to get, you're always going to get an answer, unique solution when m doesn't equal 4. Now the one other thing that might be a little tricky to understand now is I don't give a crap what k is, okay? All of this is defined around this. So in this case here, I don't care what k is. So what you can actually say is k is I don't care what it is. K is just any real value. Alright. Now this is the interesting part. I know that I get a unique solution when it doesn't equal 0. Let's find out what happens when I let m equal 4. If I let m equal 4, this will be 0, and what will happen is I'll get this situation or this situation, and in some cases I can actually get both. Okay? So let's actually let m equal 4. So if m equals 4, if it's 4, I just sub it straight in. So watch this. I'm going back to the original equation. Okay? So if I sub in 4, I get 4 take 2 times x plus y equals 2. And then I've got 4 times x plus 2y equals k. Okay? Tidying that up, I've got 2x plus y equals 2, and then I've got 4x plus 2y equals k. Now, that's an interesting situation. Okay? Can you see something interesting about those equations? Remember that PowerPoint we did? How do you know if lines are parallel? Come on. Actually, no, I'm going to keep going because this is on video. They're parallel if they're in the same ratio. Look at that, that's 2 to 1. This is 4 to 2, which could be simplified down to that, okay? Why don't we do that quickly? Let's divide this whole equation by, well, actually, let's leave it like that. Can everyone see that this equation, if you double it, you get to this? Okay, let's use that thought now. If I want this one to be parallel, it is, okay? Basically, because if I double this and double that, I get that. So I know it's parallel. Now this is the interesting part, okay? I'll just write it in here. If k was actually equal to 4, what would happen? So we still, remember we've said m is 4. What happens if k is 4? What is that going to be? Same equation. If it's the same equation, how many solutions have we got? Infinite. Okay. So if k is 4, we have infinite solutions. I don't even think we had to answer that. Oh yeah, we did. We had to answer all of them. So if k is 4, we have infinite solutions. Okay? So if k is 4 and m is 4. Okay? So in that case here, we've got that situation. Now, if k is something else, okay, why don't we do this? And m is 4, okay, we have the last scenario. So let's have a look at it again. If k was some different number, remember how we used that PowerPoint. Parallel lines are when this and these two are in the same ratio, but we don't give a crap what that number is. Remember we said that that number is different. So this number could be 50, it could be 0, it could be a billion, it could be whatever we like, okay? It could be whatever we like, but it can't be one value. It's going to be everything excluding which value? 4. So k can be anything here, as long as m's 4 and k is anything except 4, we'll actually get the other scenario which we call no solution. Okay? So you're going to get parallel lines in that case. So that's the two scenarios we've got there. Okay? Now these can take on many different forms, and that's what we've got here. So if k is 4 and m is 4, meaning we've got, and we'll just rub it off now, we've got, so if k is 4 and m is 4, this is what we get, which is the same line, which means infinite solutions. If k was anything else and m was 4, which is what we've got here, so let's put in here 20, they're parallel lines. Okay? Difficult, but that's it. Okay, we're going to put that on YouTube and we'll see how we go. Thank you.